So here's our third and final example for transposing. We have y is equal to x plus 1 over x minus 2, all minus 5. So here are x terms that we're going to be trying to isolate. So let's work opposite bedmass again. Now it's important to bear in mind here that our x terms here are tied to the fraction. So when they're in a numerator or a denominator, it's implied that they're in brackets. So that's going to be part of the brackets portion that we see here. When we're looking at addition and subtraction, what we're looking at is this lone minus 5 right here that we want to move over to the other side of the equation. So I'm going to do the opposite of minus 5, and I'm going to add 5 to both sides of the equation. So I get y plus 5 is equal to x plus 1 over x minus 2 minus 5, and I'm adding 5 to this side. These two terms cancel each other out. So I can simply erase them now. So now that I've gotten rid of all of the addition and subtraction terms outside of this portion here with implied brackets, I'm going to go up to division and multiplication. I'm going to take what we are dividing by on this side, keeping the brackets there, and I'm going to do the opposite and multiply both sides by x minus 2. I'm going to change that to a star so we don't confuse that with x. Now it's important that we consider this y plus 5 term, that it also has implied brackets. So multiplying both sides by x minus 2, I get y plus 5 times x minus 2 is equal to x plus 1 times x minus 2 all over x minus 2. And these x minus 2 terms cancel each other out, so we can ignore them, and they are essentially erased as well. So now I'm going to bring my x terms together, but it's not so easy this time. I'm going to have to multiply out these brackets. So first I'll deal with the y term, and I get xy minus 2y, and then I'm going to deal with the 5, plus 5x minus 2 times 5 is 10, is equal to x plus 1. Now I'm going to try to bring all of my x terms together on the same side of the equation and remove everything else. So I'm going to bring this x term over to this side of the equation, and I'm going to move this 10 that doesn't have an x and minus 2y term doesn't have an x over to the other side of the equation. So what I am going to be doing in essence is I'm going to be subtracting x from both sides of the equation. Because we're subtracting 2y on this side, I'm going to add 2y to both sides of the equation, and I'm going to add 10 to both sides of the equation. So I have xy minus 2y plus 5x minus 10, and now I'm going to add in this minus x plus 2y plus 10 is equal to, on the other side, x plus 1, and I have to do the same thing, minus x plus 2y plus 10. So now let's simplify this. I have minus 2y and plus 2y, they cancel each other out. I have minus 10 and plus 10, they cancel each other out. I have x minus x, they cancel each other out. I can write this out a little bit cleaner as xy, and then I've got 5x and minus x, so that's the equivalent of 5 minus 1x, or 4 x's, is equal to, and I've got 2y over here, and then let's count our constants. I have 1 plus 10, so I have plus 11. So now I'm going to factor my x out on this side of the equation. So I have x times y plus 4 is equal to 2y plus 11. And now to isolate x, I'm going to divide by y plus 4, because it's the opposite of multiplying by y plus 4. I'm going to divide by y plus 4 on both sides of the equation. I get x times y plus 4 over y plus 4 is equal to 2y plus 11 over y plus 4. And this y plus 4 and this y plus 4 cancel each other out. So I'm left with x is equal to 2y plus 11 all over y plus 4. That concludes transposing equations.